Hi, good afternoon again, everyone. I hope you can hear me. My name is CP David of the National Institute of Geological Sciences in UP Diliman. And together with me is my co-moderator, Dr. Gay Jane Perez of UPIESM, as well as Dr. Jerry Bagtasa, also of UPIESM, who will talk to us more about forecasting and meteorologic models. Essentially, what we wanted to do this afternoon is to try to understand what actually happened during Typhoon Ulysses, wherein it seems that everyone was caught off guard. And this is reminiscent of 2009 Ondoy and Pepe. And we just wanted to understand better what happened during this particular event. We are also joined by Dr. Giselle Concepcion. Ma'am Giselle, are you there? Because this webinar is part of a series of webinars that PAASE is organizing, and this is REC-12 of the PAASE's webinar series. Ma'am Giselle, if you want to say a little bit more about PAASE, it would be an opportune time to do it.
Thank you, CP, and thanks, Gay, for organizing the second of a series or round robin of REC Research Expertise Cluster led webinars of the PAASE. So PAASE stands for the Philippine American Academy of Science and Engineering and is comprised of about 380 PhD level scientists and engineers of Philippine descent based here in the Philippines and also in the United States and elsewhere in the world. And as part of our mandate, we want to spread the value of science and engineering amongst us and the rest of the country. We want to champion STEM education at all levels and improve the scientific literacy of our country. And I think that one recurring theme we have in PAASE is outreach to Philippine regions. And there's no better time than to pursue these goals than during the time of crisis, catastrophes, disasters, pandemic, and also the typhoon. So thank you very much, CP and Gay, for deciding very quickly to focus your REC-led webinar on the Typhoon Ulysses. So thank you everyone for joining, and we are on a very, very exciting recruiting mode in the past, and we want to grow it as one of the biggest organizations of Filipino scientists and engineers here and all over the world. Thank you.
Thank you, Ma'am Giselle, for also attending. Okay, full disclosure, everybody. As we speak, we are still gathering all the necessary information to, at the very least, on a scientific, technical level, we can fully explain to everyone what actually happened during Typhoon Ulysses. But that might take time, no? Because data gathering and analysis would take time. So instead of doing that and presenting what we learned about this particular event, Jerry, Gay, and myself decided let's present now whatever we have at this point in time and ask people like you guys to chime in on your own observations, perhaps, or even if you have your own data. I know Dr. Bill David of NWRB would have some data on dams as well, no? And therefore, what we will do now is to just present data that has been generated by us no, in very short presentations, starting with Dr. Jerry Bagtasa, followed by myself, and then Gay, and then just open the discussion, no holds barred discussion right afterwards. In the meantime, I'd like to ask everybody to mute yourself as we welcome Dr. Jerry Bagtasa. Jerry, you can now use your share screen to
It's
present.
still
Thank you, everyone.
disabled. Still disabled yung share screen.
Okay, Rich, sorry, I can actually enable there. Okay, and for everyone else, please mute yourself.
Okay, good afternoon. Yes, good afternoon. So I'm going to present the meteorological characteristics of Super Typhoon Rolly, Ulysses, and the others. Those that came successively ng mga tropical cyclones. So again, I'm Jerry Bagtasa with IESM. So on Twitter, I'm weather_Manila. On Facebook, I'm Weather Manila. So this will be the outline of my presentation. So tropical cyclones in the Philippines, and what's the connection between tropical cyclones and climate change. So I'm going to show you the model precipitation forecast for the successive tropical cyclones starting from Ofel, Pepito, Quinta, Rolly, Siony, Tonyo, and Ulysses. And then relate what is it with climate change that's affecting us, if it does affect us. So kung may time pa, I'll discuss some of this later. So TCs in the Philippines, annually, we have 19.4 TCs that enter the Philippine area of responsibility. Not all of this affect us. So it's just the delineation of the meteorological region that we have. Around half these numbers, around 9 or 10, they make landfall. So those are the tropical cyclones that do affect the Philippines. So TC classification is based solely on maximum sustained wind speed, and rain has nothing to do with TC classification. Rainfall is most intense around the inner core of a tropical cyclone, and as you go away from the inner core, so it weakens around the outer core. However, for the Philippines, there's an interaction between TC and monsoon that also brings TC-induced rainfall here. Later on, I'll show you. So there are many factors for the weakening of tropical cyclones. So there's land friction, you have cooler inland waters, the environment, there are changes wherein it can weaken considerably tropical cyclones within a short span of time. And also, there's a lot of talks about mountains protecting us from the tropical cyclones. However, mountains can also exacerbate rainfall. So it doesn't really, or rather, it protects us to a certain extent, but not all the time. So in case you're not familiar how TC intensity is derived, basically TC intensity is derived by looking at how it looks on satellite data. So it's called the Dvorak technique or advanced Dvorak technique, wherein you look at how ATC appears on a satellite, look at its shape, look at its rain bands and so on, and then you score points to the appearance of the TC. So once you have the score, it's called the CI number. Then the CI number is converted to the mean sea level pressure. And then after converting to mean sea level pressure, you convert to maximum wind speed. So in the Northwestern Pacific, what we use is a 10-minute sustained wind using the COBA table. So it's a paper by a Japanese scientist in 1989. For the US, they use a 1-minute sustained wind using the Saffir-Simpson scale. So essentially, we get the same mean sea level pressure for tropical cyclones from the score of a TC appearance, and then the conversion to maximum sustained wind to nagkakaiba between Northwestern Pacific and the US. So TC rainfall contributes significantly to total rainfall in the Philippines. You look to the leftmost image, this is total rainfall of the Philippines. And you look to the middle image, this is TC rainfall. Note that yung scale is different, it's half. So what we can see is the northern half of the Philippines gets a considerable amount of TC rainfall. So if we divide TC rainfall with the total rainfall, what we get is a TC percentage contribution. Percentage contribution for most of Luzon is more than 40%. For most of central Luzon is around 30% or so. For Mindanao, it can be less than 10%. And the highest is along the western coast of Luzon. So most TCs, they pass by northeast of the Philippines. However, nandito yung maximum rain contribution. And the reason for that is because of the TC-monsoon interaction. So if we look at the 85th, 95th, and 99th upper percentile of rainfall along western Luzon, more than 90% of the time, there's a TC that coincides with those heavy rainfall events. So, is there a connection between the TC? By the way, no, itong graph na to are density plots of TCs. So the larger the boxes, that means more TCs are moving along those regions. So for the 85th, 95th, and 99th percentile rainfall, so very heavy rainfall events along northern Luzon, what we see is that TCs are mostly along an imaginary line crossing Okinawa and northern Philippines. So pag doon tumaan yung TC, we get very high precipitation. And it turns out that the TCs that are passing through this region, they induce very high water vapor flux. So basically, there's a lot of moisture transport which originates from the Indian Ocean. So because of the TCs that are located in this region. So usually, ang tawag locally is the enhancement of the habagat. So that is also considered as TC-induced rainfall. So in terms of climate change, this is what we know. TCs are intensifying due to increasing sea surface temperature globally. So two of the most famous papers is from Emmanuel and Webster from 2005, wherein they connected the increasing SST with intensification of TCs. Locally, a paper in 2015 by Comiso et al. Also showed that during the time of Yolanda, it coincided with the warmest SST in the east of the Philippines called the Warmpool region. So, however, TC SST connection is arguable. There's a paper by Chan, Johnny Chan from Hong Kong, wherein he stated that most of the data that Emmanuel and Webster used are very short. And if you look at longer term data, there's actually a 16 to 32 year cycle wherein TCs become more intense during those times. So arguable pa rin siya until now. There's a paper wherein TCs are said to be moving slower by cousin, but that's for the US. And recently by Yamaguchi and Maeda in Japan. So in Japan, for example, it's slowing down because of the slowdown of the jet stream. I think it's a similar case for the US. However, there's also a comment by Professor Moon in 2019 wherein they said that data that causing use was not homogeneous and was not robust enough for such conclusion. So it's still questionable if they're indeed slowing down or being affected by climate change. The slower decay, a paper recently, I think last week or 2 weeks ago, slower decay in the US, however, not really applicable for archipelagos like the Philippines. And TCs are also becoming rainier due to higher relative SST or higher relative humidity by Lin. So what we have observed so far is that frequency of TC is actually going down globally. But for the Western North Pacific, it's not so much. Overall intensity is increasing using what is known as the accumulated cyclone energy. Globally, energy of cyclones are increasing. there are more intense TCs now. When we say intense, it's category 4 and 5 tropical typhoons or hurricanes. TCs are also migrating northward. This is projected by models from 20 years ago. However, until now, models are very poor at projecting past TCs and more so for future TCs. Changes in size of TCs is also being seen because size is a function of relative humidity. The more the moisture, the larger a TC becomes. And damages are also increasing. However, may counter dito. So better observation, better accuracy, resolution, availability of data, they can all skew recent data into having more intense and more damages kasi nga, essentially because of the better data that we have. So these are the TCs, sequential TCs from October 13 until recently na tumama sa atin. So TD Ofel, October 13, around that time, it started east of Visayas. It has this clouds all over the Philippines, and more or less rainfall started when it was very close. Tapos dito siya more on sa Southern Luzon and Region 5. So these are the observed rainfall, and these plots here are modeled rainfall from up to 2 days prior. Severe tropical storm Pepito was a bit stronger than Ofel. Also, its circulation is better organized, but it didn't really bring a lot of rainfall in many parts of Luzon. So we got Baguio or Baler, which had the most amount of rainfall, but still below 100 millimeters. For TY Quinta, it's a typhoon. If you look at the satellite, it's very organized in circulation and very symmetrical. So that means it's stronger. If we look at the simulated rainfall prior to landfall, what we get is this. So more or less, if we see like dark purple, it will be in around 100 to 200 millimeters, blacks for more than 200 and so on. So for Quinta, there was a significant rainfall in many parts of not only Region 5, but also Region 4B. Then moving on, this is Super Typhoon Rolly. So Rolly, if we look at the satellite image right before landfall, it had a large area of very, very cold tops. And the CI number, so the Dvorak earlier I showed you, yung maximum value nun is 8. So the CI number na na-score kay Rolly was 7.9, which is equivalent to 170 knots. So that's for 1 minute sustained winds. For 10 minutes sustained winds, that's 225. So it reached the 220 threshold of super typhoon for PAASE. However, after landfall, there was very unfavorable environment when it was around here. So this is Rolly at 8 a.m. of November 1. So the red lines are showing the unfavorable conditions because of wind shear. So there's shearing of wind and basically it kills a typhoon. And by 2 p.m., there's actually a very unfavorable environment. And that's the reason why Super Typhoon Rolly, during landfall, it was really intense, but just a few hours after that, it dissipated its energy. So this is the forecast rainfall for Rolly, and most of the rain are along Region 5. Siony and Tonyo, so in between Rolly and Ulysses, they had this, but they were very small. So for Siony, it was very small and affected the southern part of Taiwan, in fact. So did it really affect the Philippines anymore in terms of rainfall? For Tonyo, it's there's a thing what you call the exposed lower level circulation. So basically, there's wind, there's circulation, but basically there were no clouds. So naalala ko si Tonyo in Manila, it was in fact sunny during that time. So did it really affect us? And the rain in the northeast part of Luzon is actually from the cold front to the north, not from Tonyo itself. For TY Ulysses, it was really large. So the size from end to end of the rain bands is around 1,300 kilometers. That's unusually large. And it's large because of the very high relative humidity, very high moisture during that time. As early as Sunday, if I remember, that's November 8th. So as early as Sunday or 4 days before, we already have this forecast for Rolly. So in terms of model forecast, it's already showing that it's gonna be really, really, really rainy. And the model forecast is more or less correct in my opinion. So in terms of wind, this is for Rolly, so it showed that there's significant reduction in wind, and by the time it reached NCR, the wind was only around 40 to 60 kph na lang. But for Ulysses, there were still 100 kph winds that were projected, which more or less was the case. Also, I did quick modeling, controlling the relative humidity of the environment for TY Ulysses. So for TY Ulysses, the model was more or less able to get the size of Ulysses. But when I changed the relative humidity to 95% of what was actually the environment, then you can see that even though at the center, the rain rate is still the same, it became smaller. And then for 90% RH, smaller even. And then for 80% RH, even smaller. So it's really the relative humidity that made Ulysses really, really large. I think I used up my time already, so I'll stop here. Thank you.
Thank you, Jerry. Ang dami kong notes dito about your talk, but basically for our audience, the takeaway messages at least on my part is number one, when we estimate wind speeds of tropical cyclones when they're still in the ocean, this is purely based on image analysis of satellite imagery using the Dvorak method, which was, I think, ano bang year yon? Medyo matagal na yon eh.
Oh yeah, matagal na.
And therefore, it should come as no surprise to everybody that these estimates of wind speeds may entail a fairly wide range, because we are interpreting the winds that are contained in a tropical cyclone based on our satellite images. And there's no actual measurement of maximum sustained winds within its eye wall, for example. The second takeaway message, Jerry, from your talk is that you're saying that although we cannot concretely say that this is a hallmark of climate change, there have been many papers suggesting that there are changes in the characteristics of tropical cyclones passing through the West Pacific. Is that correct?
Yeah, but the thing is, there's so much variability, not only from year to year, but from cyclone to cyclone, that it's really difficult to see the signal of climate change.
Okay. Yeah. But at least there are reports in terms of patterns of increasing intensity because of humidity. There is also a pattern of, in terms of track, Jerry, meron pang changes?
In terms of track, ito nga sana ipapakita ko next one. So globally, it's going northward. It's migrating northward. So the wind effect, the rainfall effect, everything are going northward. For the track in the Philippines, it's a little bit different because of what you call the Western North Pacific Subtropical High. So this Western North Pacific Subtropical High, it's been strengthening over several decades. So as you can see, yung line here. By the way, no, this is very important since a tropical cyclone would only move along the periphery of the subtropical high. Hindi siya lalagpas. So kung mahina siya, it will move towards Japan. Kung malakas siya, meaning westward extended, then it will hit the Philippines. So throughout the decades, so this is from let me see, no, from 1975 to 1984, and then 1985 to 1990s, mid 90s, and then mid 2000s, and then until 2015, it's been getting stronger and stronger or being extended westward. So ibig sabihin ito, in the last decade, for example, we had more hits dito sa lower part of the Philippines, southern part of the Philippines because of this. I think in terms of, sige, go ahead, sorry.
If I may summarize what you just said, no, there are regional meteorologic structures like high pressure areas that actually control the track, no, whether it will curve or go from east to west of the tropical cyclones that hit the Philippines. And there is also some variability in their occurrence in terms of timing and place. And these are all affecting where tropical cyclones, typhoons are passing through.
Yes.
Okay. Great. Thanks, Jerry. Just to remind everybody to use the chat box if you have questions. Pero hindi ko na mapigil yung sarili ko. Jerry, I have to ask you, what happened with Super Typhoon Rolly? It was billed as a super typhoon, fairly similar to Yolanda, and yet, at least here in NCR, we didn't feel much of its strength. Naubos ba siya sa Bicol? Is that what happened? Because hindi wala masyadong ulan.
Yeah. So si Typhoon Yolanda was in terms of CI number, the Dvorak, it was pegged at around 8.2, which is literally off the charts kasi hanggang 8.0 yung chart ng Dvorak. So that's why it was at around 235 or 240 kph for Yolanda. But the thing that happened was this wind shear. So of course, when tropical cyclones, when they interact with land, they slow down. Pero if you remember Glenda or Milenio, they also passed by a very similar track. Pero pagdating ng Metro Manila, malakas pa rin sila. Pero ito, dumaan ng Bicol region, but as soon as it hit Catanduanes, itong red lines, the shears, so very strong shear, so killing off essentially the outflow of the tropical cyclone, of the typhoon. So in just within 9 hours, it was able to weaken Rolly significantly. I was quite surprised that hindi na downgrade yung signal number. So I think that's the reason why for Ulysses, everybody was complacent because na over forecast si Rolly. So it's like the boy who cried wolf for Rolly, and in a very short amount of time, sumunod tong si Ulysses.
I think there's some truth to that, although wala tayong hard data, but just asking friends in Marikina and in Tumana, that's precisely what they thought, no? May dumaan super typhoon, it didn't affect them. The warnings were there, and then during the time of Ulysses, the warnings were not as glaring from the LGUs, and therefore they became complacent. No? So definitely that's a factor that happened with Ulysses. Okay, thanks, Jerry. There are questions in the chat box, but we can go through them during our Q&A. So just keep on typing your questions, and we'll proceed with our presentation. Mute po. Everybody, please mute your microphones. Okay, we can still hear you. We'll proceed now. So again, my name is CP David. I'm a geologist by profession. But since 2009, since Ondoy, basically I've been working with PAASE and our meteorologists on certain projects, the last of which was to create a program to utilize PAASE's radar network and data so that we can do accurate, almost near real-time forecasting of rain events. Uh, I invited our friends from PAASE, but unfortunately they weren't able to come. However, they provided me all the information in terms of rainfall that occurred, and this is what I intend to present to you this afternoon. So just to continue with Doc Jerry's presentation, this is the track of Typhoon Ulysses, very, very similar to the track of Ondoy, if I may say so. A quick comparison between Ondoy and Ulysses. Total rainfall for Tropical Storm Ondoy was 448.5 millimeters. But what is significant during the time of Ondoy is that a good amount of that 448, in fact 347 millimeters of rainfall fell within just a 6-hour period. And this is data from, I believe, from a station in NCR, and definitely the rainfall that fell in the upper reaches of Marikina River in the Montalban area were definitely even higher than 347 millimeters in 6 hours. Relating this to the amount of rainfall that fell during Ulysses, on November 12, 2020, 356.2 millimeters of rain was recorded in Rizal, over that one-day period. Much of it fell within a 12-hour period, but definitely not like Ondoy, which had much of its rainfall falling just within a short period of time in terms of the duration of the rainfall. Okay, I'll leave this figure a little bit longer than my other slides because this is a summary of all the rainfall that fell in all the stations within the general vicinity of the typhoon based on our stations of PAASE. And you can see here that the most rainfalls happened in Tanay Rizal, in Daet, Camarines Norte, and Infanta Quezon. The colors, by the way, in the bars represent the amount of rainfall that fell during November 10, which is the light blue bar, November, this is a 3-day rainfall accumulation, November 12 for the dark blue part of the bar and the 10, 11, and 12. 10, 11, and 12 amounts of rainfall. Now, this seems to not mean a lot, but if I just rearrange this table in this manner, okay, and they are arranged from west to east, meaning that when the typhoon entered the Philippines, the first that was hit was the station in Virac, Catanduanes, okay, and then you go from east to west, from Catanduanes to Iba Zambales, from right to left. And therefore, obviously, much of the rainfall during the first day, November 10, the light blue bars, you will see that happening in the stations towards the east, and the light green part of the bar, which happened later on, November 12, you will see them towards the west side when the typhoon finally moves from the Bicol area until it exits through Zambales. Okay, does that make sense? Now, what I want to point out here is that just by looking at the green part now of the graph right here, okay, so definitely we see a lot of rain towards the west during the latter part of this 3-day period, no, November 12th. But what is surprising here is that Tuguegarao City, Cagayan recorded so much rain on November 12th, where in fact the typhoon should have passed this area already by much of November 11. No? So this is something peculiar, and I had to ask my meteorologist friends, parang bakit na late yung ulan dito sa Tuguegarao? And now everyone knows that it flooded Tuguegarao City along with dam releases that happened in Magat Dam. But really, this significant amount of rainfall that happened pretty much in the outer rain bands of Typhoon Ulysses, no, fell at the later part of the typhoon. No? So this is something that's pretty unusual. And one of my colleagues in the National Panel of Technical Experts, whom I think is also here with us in the Zoom meeting, Dr. Amadore, mentioned something about a mesoscale structure, which is if you may, it's like a typhoon, no, within a typhoon, or a portion of the typhoon that simply contains so much rainfall, and therefore the distribution of rainfall typically going from the middle of the typhoon, and as you go outwards towards its outer rain bands, you should get less rainfall. It seems that it was not followed in the case of Typhoon Ulysses, because you get that significant rainfall in its outer rain bands, probably because of a mesoscale structure within that typhoon. Now, what is worrisome on my part when we see this is that it totally screws our forecasting and predicting capability, because everyone knows that we are looking at a typhoon based on where the location of its eye would be, because this is where much of the high winds, no, the strong wind speeds will be felt, as well as rainfall pretty much concentrated in the middle of the typhoon. Now, if it so happens that the distribution of rainfall in some cases, like the case of Typhoon Ulysses, that you may have these cloud bursts and heavy rainfall towards the outer rain bands, then our forecasting will have to change, you know? And we will have to be more wary about these structures or distribution of rainfall within a particular typhoon. Here's the cumulative 3-day precipitation data, which I showed you in map form, and you can see that much of the rain fell in the Camarines Norte area and Rizal, and like most typhoons, it actually weakens as it enters land and exits towards the West Philippine Sea. The distribution, however, is not uniform as what we expect, with much of the rainfall always at the center of the typhoon, because it doesn't show in this figure. And at the same time, that distribution of rainfall within a typhoon can vary significantly. Here's another data set that I wanted to show you on rainfall. These data come from the automated weather stations run by DOST-ASTI. Now, they're automated, and therefore they provide 15-minute rainfall recordings. They are, up to this point in time, not all of the stations are calibrated, so I'm still not going to advise that we use all these stations, but nevertheless, the trends of rainfall, we should be able to see at a finer detail because 15-minute interval ng collection ng data na to. Here's a typhoon track of Ulysses, and nearest to it are the stations, automated stations in Caramoan, in Daet. This one is in Norsagaray, Angeles, and this one is in Zambales. Now, what I wanted to point out here is that obviously the timing of rainfall in each of these stations will not be at the same time because the stations and the areas towards the east will feel rain and winds of the typhoon much earlier than those towards the west. Now, one idea, because there is that issue of being able to predict as much as possible, as accurate as possible, how much rain are we going to receive. Now, this idea uses actual rainfall, no? So, in other words, ang idea dito, pagka papasok pa lang yung bagyo, no? Let's look at how much rain it's carrying, no? By looking at the data in our weather stations towards the east. And there is that lag time before that typhoon actually hits the other areas. By that time, we have a better sense of how much rain there is, how much, what is the strength of the winds within the typhoon. And that should make us prepare, even better compared to our forecast when the typhoon was still in the ocean. The data from these weather stations from Camsur, in Quezon, in Bulacan, Pampanga, and Zambales are plotted here. The blue line is for Camarines Sur, and as you can see, the amount of rainfall peaks in this portion at exactly 4 p.m. of November 11. The peak rainfall, on the other hand, in Quezon, I believe this is in Infanta, occurred at 9 p.m. For Bulacan, it occurred at 3 a.m. In Pampanga, in Angeles, it occurred at 5 a.m. And finally in Zambales, 10 a.m. Now, what I'm saying here is that there is a significant amount of lag time as the typhoon passes through the Philippines. And this lag time, 5 hours, 8 hours, even 13 hours lead time of knowing how much rain there is a wealth of data for us, at the very least, for those towards the west, be able to prepare, and expect with greater detail how much rainfall there would be before the typhoon hits us 5, 8, or 13 hours before it does. So we haven't capitalized yet on this type of information, but I hope that we can utilize this rich data source and augment our forecasting capabilities for typhoons to come in the future. I think I'll stop there, and I'll be open to questions from the audience afterwards. But at this point in time, I'd like to turn over the floor to my colleague and co-moderator, Dr. Gay Perez.
Yes, thank you, Sir CP. As much as I want to present a synthesis of what you said, actually there are recent developments. Ma'am SP Kayanan of PAASE is with us in the webinar. And there are a couple of presentations from PAASE po, from forecaster, si Sir June and si Sir Max from the flood group. But so they can present after me. Bibilisan ko na lang po yung sa akin. Then maybe mamaya na lang, Sir CP, yung synthesis natin, no? Okay, can you now see my slides? Hello? Yes. Okay po. Okay, so let me proceed. So I'll be presenting data as seen from space naman. So while I'm giving the presentation, so actually this is a work by our group at PAASE, and they are also joining us here sa call. Okay, so how much rain did it bring? Doc CP presented quite comprehensive information already regarding rainfall from the different stations. So this is just providing the special context. So this is for November 11 to 12. So we can see most of the rainfall in the eastern coast, some part of southern Luzon, as already mentioned by Doc CP. The value ranges from 200 to even maybe close to 400 millimeters. No? But we also see this special variability. So I think that's also something worth looking at. Now, this one is the climatology for the month of November from year 2000 to 2019. This is the total accumulated rainfall for the month. And what we see here is the rain that we experienced for 2 days in most areas in Luzon were actually more than half of what it would have received for a month. Shown here is the percentage equivalent. No? So how much of the monthly rainfall was received in 2 days' time, while yung close to 100% is actually on the western part. Also note that the western side really do not receive as much rainfall anyway. So even if it received close to 100% of rain in just a couple of days, maybe there's not, well, the volume is still not that much compared to other places like in Cagayan and Rizal. So this is essentially like a supporting figure to what Sir CP already showed earlier. Only this time it's taken from satellite observation. The colors are from aggregated for different provinces. Blue is for Cagayan. And I guess what's remarkable here, we are looking at Typhoon Ulysses, which is this November 11 and 12. Ito yung sinasabi ni Sir CP kanina na mas madami yung November 12 actually. But if you look at November 8, there was actually much higher rainfall that fell in Cagayan area. No? And the plot below is the cumulative rainfall from November 1 to November 13. So at the end of November 13, the total rainfall is now close to 400 or even more than 400 millimeter for Cagayan. And the orange one is for Catanduanes, blue is for Rizal. So Rizal also received quite a bit of rainfall, no? If you accumulate it through time. And even more, you go back 15 days earlier to cover Typhoon Ofel, yung pinresent ni Sir Jerry kanina. Sorry, natakpan. Ayan, the rainfall in Cagayan is actually close or more than 800 millimeter. So I did not show the time series before this, pero meron pang mga peaks, no, in this period. So this is just the accumulated rainfall. Okay, sorry for our dogs. Okay po. So compared to the monthly climatology, so this is the percentage of what was received only for these 2 days, 2-day period. No? So Rizal received 62.47% of rain. Cagayan is 40.53%, and so on and so forth. Maybe we can go back to this later sa discussion, because I still have a few more slides to show. Now, so with so much rain, Typhoon Ulysses led to massive flooding. So these are some satellite images showing the flooded areas. Now, we saw a lot of news regarding flooding in Rizal and Cagayan, but actually flooding were also experienced in other parts of Luzon, like here in Oriental Mindoro. So this is a 2 images, no? November 13 and November 16. So even 4 days after, a large part of the area is still submerged in floodwater. Similarly, we saw flooding in Nasugbu, Batangas, in Lopez, Quezon, and here you can see very well how the Pampanga River has swollen and flooded low-lying areas in Nueva Ecija, Pampanga, and Bulacan. So with these satellite images, we are able to estimate the extent of area flooded using normalized different water index, but only for those that are visible to us. So as you can see, this is the swath of satellite image, and a large portion of the country is obscured by clouds. So, but for those areas that are peeking through clouds, so we can estimate the area of flooded waters. So, but actually, the group from ASTI, Datos group, were actually able to map a more comprehensive extent of flood using SAR images and artificial intelligence. So they were able to estimate flooded area in Cagayan. So this is the one on the right. It's orange. Colored pixels here. The yellow area is actually the farmland, which we downloaded from NASA, just to show how much of our farmland were actually affected. The one on the left is of Bicol region, and so we can also see the massive flooding. As of November 18th, so a couple of days back, the Department of Agriculture, DRMM, already reported an estimate of 13.5 billion pesos worth of damages to agriculture. And we can see that the evidence here. Now, the typhoon not only led to flooding, it also led to widespread power outage in large part of Luzon. So as shown here in the nightlight images, so these are just a couple of images. One is a composite of a 3-month period from August to October, and then the other one is within November 13 to 17. So it's quite obvious the places that were like nagkaroon ng lights off, no? So parang malaking area po yung nawala ng power. And I just want to say that this is actually a conservative estimate in the sense that those areas that experience power outage for a limited time or short time, hindi na siya nakikita dito kasi maiksi lang yung period na walang power outage. So it was compared with census data of 2015, and the team estimated that this is the percentage of the affected population. So for Cagayan, it's 62%. No? So several were really affected and experienced extended power outage. And the same is true for Quirino. And then it's not that bad in Isabela and Nueva Vizcaya. Now, Sir Jerry already mentioned about the possible connection with climate change. And although he mentioned that it's still arguable in the sense that there is a big variability, I'm just sharing here what we saw from satellite data. So this is the sea surface temperature from November 1 to November 14. And the warm pool region is this area here. So it's really red, sorry. This is in degrees Celsius. Now, if we look at the time series from 1981 to the present, so this is the value of the sea surface temperature averaged over the warm pool region. So this is the area. And sorry, okay, if you look at the anomaly, which is the difference from a base period, there's still a positive trend. No? It's roughly about 0.23 degrees Celsius per decade positive trend. I just want to point out where Yolanda is. It's the peak among these different observation. And this is Ulysses. So if we are comparing, say, Yolanda and Ulysses in terms of like what's the SST in the warm pool region that time, in terms of anomaly, the temperature in Yolanda is still much higher than that of Ulysses. But if going back to like the absolute value, it's not that far. No? This is close to 30 degrees. This is above 30 degrees. Now, this is my last point. Is deforestation a contributing factor to the flooding? Okay, there were reports citing that this as a reason. Again, this is, I guess, more of a subject for discussion. But what I just wanted to share is our study that came out this year, where we look at Luzon area and look at the deforestation. So this is from 2001 to 2018. The lighter green is the open forest area, and the dark green is closed forest area. And what we're showing here is that there is deforestation, continuing deforestation in Luzon. So this is for Luzon. And the figure below is for Sierra Madre, where the red is the estimated forest area. So there is a quite a bit of a decline, while the green is actually supposedly the extent of the NGP area. So as many of you know, there is an ongoing national greening program. So we look at how the national greening program fares well compared to deforestation. And the NDVI is sort of like the net. So when you look at the net, there's not much of an improvement, but also take note there's a big standard deviation. So there's a big variability there. And I don't know how much time I have, but this is for a study area near Ilagan, Ilagan Isabela. And there are 3 periods here: 2008 to 2010, 2014-16, and 2017 to 19 period. And the movements that you see here, green is closed forest, light green is open forest. So essentially what it's saying is there are 1,706 hectares of closed forest that was converted or became open forest in this part, although there is also a gain, no, from open forest. 2,430 hectares became closed forest. So that's quite positive news. However, in another study site, this is close to Rodriguez, Rizal. The story is not that positive because, as you can see, a large fraction of the closed forest became open forest, and also some parts of the open forest became sparse vegetation. Okay, so essentially that's it. Maybe later sa discussion po, I can go to some of the slides. I just want to give more time to PAASE to also give their presentations. Thank you.
Thank you, Gay. Just to summarize your presentation, you mentioned that the flooding that we experienced because of Ulysses have compounding factors that affected the height of the floods. One is potentially all the rainfall that fell prior to Ulysses, which you mentioned that there's a significant amount of rainfall that fell days or even a week before Ulysses in Cagayan, and that may have exacerbated the flooding there. Rene Reyes actually pointed out the role of the dams, and definitely that there was a role in the release of waters and contributing to the flooded downstream areas of Cagayan, definitely. I invited Dr. Siringan to talk more about the situation in Cagayan, but he's still there doing field work. And so we can't get more information, no, about the role of the dam releases in terms of the flood heights that we saw in Cagayan. At this point in time, we'd like to give 10 to 15 minutes of our time, if that's okay, to our friends in PAASE from the weather forecasting group. I don't know who.
Sir, si Sir June po is here.
Yes, magandang hapon po.
June Galang?
Yes po.
Okay.
Yes, sir.
Hi June. I'll
Magandang
make
hapon,
you
sir.
a co-host, and if you want to share a few slides, you have 10 minutes. Thank you, June.
Okay na po ba? Okay. Ito, basic presentation lang po dito sa Typhoon Ulysses. Ito yung outline na aming presentation, yung chronology, analysis of intensity, wind radar, and observed rainfall. Medyo bibilisan ko lang po. Ito po yung track ni Typhoon.
Presentation view, June. Sorry.
Share ko po, isi-share ko po ulit.
Tapos presentation.
Share na, sir.
Si Ma'am SP ba is also with us?
Ayan, okay na po. Ayan, okay na po ba, sir?
Yes, Sir
Yes,
CP.
yes.
Andito
Okay.
po siya.
So, bibilisan ko lang po. Ito po yung initially northwest ang track ni Ulysses, then nag-westward siya at nag-landfall siya as typhoon intensity. So, ito po yung chronology niya. As of November 8, first noted as tropical depression. Then the following day, nag-intensify siya into tropical storm. On the next day, naging severe tropical storm. And on the following day, naging typhoon na. So, first landfall niya sa may Patanungan, Quezon, around 10:30 p.m. And second landfall sa may Burdeos sa Quezon din po, 11:20 p.m. And then on 1:40 a.m. of November 12, third landfall po siya dito sa may General Nakar sa may Quezon. So yung kanyang center nag-emerge dito sa western seaboard ng Zambales at 8 a.m. nakalabas na silang landmass. So on November 13, nag-weekend na siya into severe tropical storm. Then nag-re-intensified uli into typhoon, then exited par at 9:30 a.m. So ito po yung itong left, ito po yung ginagamit nating radar sa may Daet, sa may Camarines Norte, na eventually nasira na yung isa, yung sa may Birak, kaya ito na yung sumalo ngayon. Tapos itong right, ito yung animation ng mosaic sa mga PAASE radar. Yung sa may Daet, ito po yung ginamit namin pang track. Napaka-helpful po nito nung pang-track ng center ng Typhoon Ulysses. At pati na rin sa rainfall at wind estimate. So, yung mga ginagamit po naming tools regarding the intensity, una-una po yung Dvorak satellite analysis na nabanggit po ni Doc Jerry kanina. Gumagamit din po tayo ng objective intensity guidance gaya ng ADT, tsaka yung satellite consensus. And then ASCAT, and then the ship reports and synoptic, tsaka upper air observations. So ito yung animation lang ng microwave imagery sa mimic galing sa SIMS. Isa po nito ang ginagamit natin kung makikita natin dito kung magi-intensify na ang isang system. Nagpapakita po ng signature agad dito. So ito po yung actual na Dvorak analysis natin ng mga kasamahan natin sa may satellite section. So sa wind radar analysis, sa pag-analyze ng 30 knots, 50 knots, saka 64 knots, magamit po tayo yung ASCAT. So in the absence of ASCAT, meron tayong empty SWA, tsaka yung ADT, yung automatic Dvorak technique. So ito po yung ASCAT natin, sample ng ASCAT, itong nasa left side. Sa right side, itong sa empty SWA. So pakita lang po yung wind signal regarding to sa tropical o Typhoon Ulysses. Kumbaga itong nasa Central Luzon down to may part ng Southern Luzon, NCR area, sa signal number 3. And then yung mga extreme big gust observation, pinakamataas po rito sa may Daet sa Camarines Norte and followed by Infanta, Quezon. Lahat po ng nasa may eastern section ng Central at Southern Luzon nakapag-record ng big gust. And then ito po yung sample lang ng mga heavy rainfall forecast na binigay natin. Kasi may mga nagtatanong dati na hindi raw po tayo nagbibigay ng rainfall forecast sa warning, sa bulletin. Kaya just sa sample lang po ito. Ito po yung ginamit namin basihan, yung WRF initialization at 8 a.m. noong November 10, 8 a.m. noong November 11, And then 2 p.m. ng November 11. Lahat po ito ginamit natin sa pagbibigay ng rainfall forecast. And then pinaplat lang po ito yung 6-hourly distribution ng rainfall. So makikita po natin dito kung saan talaga yung concentration ng mga maximum rainfall. Makikita natin na part of Southern Luzon, Central Calabarzon area, then NCR. So yung at following day, yung nabanggit po kanina ni Sir CP na medyo late itong dito sa may Cagayan Valley area. Ito na-capture din po rito. So ito po, dinivide lang into 12 hours. 12-hour accumulated rainfall, so just the same. Ito po yung yung sa forecast A, yung model output from 11:10 to 11:11 at 8 a.m. Tapos yung forecast B, model output naman ng 11:11 8 a.m. to 11:12 8 a.m. So makikita po natin na halos yung sa forecast B na mas close siya dito sa may observation ng November 11. And then some observation dito sa mga telemetered stations natin. Ang dito sa may forecast B ang mas close sa actual observation. Ito lang po yung forecast track error natin regarding Typhoon Ulysses. Yung first 24 hours is 38, followed by 54, 84, 113, 171. Thank you. Yun lang po. Salamat.
Thank you, June. And Ma'am SP, thank you for joining us today. Meron din ba tayong presentation from the flood group? I thought I saw Max in the room, or Roy.
Si Sir Max Peralta daw po.
Si Max. Max, are you there? I'll make you a co-host so you can share your slides. But while I'm doing so, baka Gay, you have questions for June or Jerry?
Sir, may marami na pong questions sa chat. I'm actually compiling it. Pero should we go now or later na lang po?
Okay, I just made Max a co-host if you want to share slides. I guess just reading the chat box, may mga tanong about dam releases and predicting the flood heights. Na baka si Sir Max Peralta can answer those. Hi Max, the floor is yours. Max.
Hello?
There. Go ahead, Max.
Sige, sir. Nakita na itong kuha namin, sir, file namin. Okay.
May feedback lang, Max. May feedback. So baka may magkalapit na laptop na open.
Okay na. Sir, ang specific lang nating topic nito ay yung sa Cagayan River Basin, sir, with respect dun sa Magat Dam releases. So, ang title natin is Hydrometeorological Report of the Passage of Typhoon Ulysses. So, just to start, sila, ba't ayaw?
Click mo lang yung
Okay. Just for orientation, sir, kung nasaan yung Magat, makikita ba itong pag-move ng sir? Tawag nito, mouse. So this is the
nakikita, Max.
This is the Cagayan River. And then nagdi-discharge for ito ng tubig doon sa Babuyan Channel. And then itong area na nandito yung part ng Quirino at part ng itong area ng Magat ay nanggagaling ang headwater sa Nueva Vizcaya. So lahat ng tubig po sa catchment area na ito, nakikita natin colored as green, yun po yung Magat area. So it is delineated na ito po yung kabuuan ng Angat and then Magat area. Okay. So ito yung mga picture ng Magat Dam. So medyo marami na nasama na po yung ibang dams dito. At any rate, ito po yung partly Cagayan River Basin, no? Yung kulay pink, delineated by pink. The area is around 27,280 square kilometers. Now, ito pong fourfold natin ay ito po yung catchment area ng Cagayan River at Gamo at Bunton, Tugigaraw. So that means to say na lahat po ng tubig na salo nitong catchment area sa may Tugigaraw ay dadaan po doon sa Bunton Bridge at iyon po yung kinoconsider natin na nagpabaha dito sa Tugigaraw. Now itong green area, ito po yung catchment area ng Magat, which is 4,143 square kilometers. At yung reservoir surface area natin ay yung pinag-iipunan po natin ng tubig dito po sa may dulo ng Magat Dam ay may area lang po na 38.90. Now just to emphasize na yung reservoir surface area, yun po yung pinag-iipunan natin ng tubig dito po sa kabuuan ng catchment area ng Magat. So the ratio, if we will determine the ratio between the reservoir surface area versus the Magat drainage area is around 38.9 over 4,000, that is 1 over 100, more or less. That means to say, ang ulan na babagsak dito ay 100 times magiging depth pagdating dito sa Magat Dam reservoir. Have explained it? Tama ba? Or any question? What I mean to say, kung ang 10 millimeters of rainfall na bumagsak dito sa area ng Magat, kung wala po siyang losses, totally surface runoff ang papasok dito sa may reservoir area ng Magat, yung 10 millimeters pwedeng magiging 1 meter pagdating sa depth dito sa may reservoir area. So ganun kaliit yung reservoir area natin compare doon sa catchment area. So sandali lang po mapuno ito dahil nga po sa itong relationship niya. So also in drainage area also between Magat at saka yung tinatawag nating catchment area ng Bunton at Cagayan Tugigaraw, that is around 4,000 over 19,000. That is almost 1/5 doon sa ang relationship between the Magat at saka yung Tugigaraw. That means to say, ang contribution ng pagbaha dito sa may Tugigaraw ng Magat is around 1/5 of overall. Ang ibig sabihin din, kung sarado itong Magat, no, ang lumalabas lang po dito ay yung ito lang pong clear area na ito dahil wala po siyang lumalabas. But pag itong area ng Magat ay nagdidrain ng tubig dito, ito po yung kabuuang area niya na 19,731. That means also to say now 1/5 of this, the volume doon sa sa Tugigaraw area is contributed from the Magat River. Kung lahat ng tubig ng Magat ay dinidrain papunta doon. Any reaction? Wala. Okay. So I just want to highlight also na sa flood forecasting and warning for dam operation, pag nag-release po ng tubig itong Magat Dam, ang directly affected na area dito sa pag-release ng dam ay yung mga downstream municipalities na dinadaanan nitong Magat River. Basically, itong Ramon, San Mateo, Aurora, Cabatuan, Luna, Mercedes, Arena Mercedes, Burgos, Nagilian, and Gamo. Hindi na po natin sinasama rito ay yung mga bayan na kasama rito sa main Cagayan River. Because itong main Cagayan River ay meron din siyang drainage area dito sa Upper Cagayan na nag-drain din dito sa Lower Cagayan. So ang ibig kong sabihin, dito sa may area ng Damo, yun po yung confluence ng Magat River at saka Upper Cagayan River. So hindi natin ma-account kung ano po yung volume na binabagsak ng Magat at the same time ang binabagsak po ng Upper Cagayan River. So iyon lang po ang winawarningan. Pag nag-release po ang NIA ng tubig dito, nagpapababa sila ng mga tao rito, ng mga personnel, para manually kanilang winawarningan yung mga directly affected dito sa mga lugar na to. So dito sa flood and forecasting and warning dam operation, NIA po ang namamahala dito sa pag-warn sa mga tao sa impending threat dala ng pagbukas ng dam dito sa Magat Dam. Okay? So I have to go back to this track of typhoon analysis. As you notice, November 11, it was being the typhoon is being Ulysses is intensified into a typhoon, and then yeah, I think we have to skip this. Then ito po yung satellite map, weather satellite map na nakukuha, or rainfall satellite map na nakukuha natin sa ibang source. So I just want to highlight this one, na yung mga red colors ay yun po yung malalakas na pagulan, as you can notice doon sa color scheme scale. So north of the sa Baguio ay meron po mga malalakas na pagulan at saka west side. Actually, sa periphery din ng Baguio, meron ding malakas na pagulan. At any rate, ito siya, noong November 12 at 1 in the morning, malakas po ang pagulan dito sa may parte ng Nueva Vizcaya, which is nandoon po yung Magat Dam. Okay? And then this map is a satellite derived map na galing po sa EOS satellites. Actually, this is processed by EIT. And unfortunately, we have some linkage with this group ng Sentinel Asia. So, nung araw kami sana ang tawag nito, process nito. But due to the poor connectivity ng satellite natin, hindi na makakapasok yung pagdodro namin ng mga images galing sa ibang bansa. So, minarapat na lang na EIT na tutun tayo pag-derive ng mga ganitong satellite map. As you notice, this area is upstream ng Tugigaraw. Ito po yung Tugigaraw area. And it can be viewed dito sa next image. Ito po yung Tugigaraw area. So this is
Max, last 1 minute.
Yeah, sir.
Sorry.
So ito po yung coverage na binabaha ng satellite as viewed from the satellite. And then, sorry. Sa area po dito sa may Babuyan Channel, ito po yung mga binabaha. Ito yung Apare, and then part of this is yung Alcala. Then we have also forecasted yung mga event rainfall sa mga panahon na yon. Actually, nagsisend kami sa Angat area from issued at 10, between 10 to 11 in the morning doon sa 11 of November. This value para lang po mag-guide namin ang mga reservoir kung ano po yung darating sa kanilang ulan. As in the case in Magat, we forecasted an event rainfall of 160 mm, which will reach the 193 levels doon po sa Magat area. And then this also is the comparison between Bunton discharge with compare to the Magat discharge. As you notice, ito po yung peak ng Bunton discharge. So it's around 27,000 cubic meter per second compared to 6,000 na maximum outflow ng Magat. So as you can notice, 6/27, this is the actual value ng ratio ng discharge ng Magat with compared doon sa Bunton area. So kanina, ang sabi nga natin, almost 1/5 yung contribution. It goes to say na dito sa relationship nito, 6/27, nasa 1/5 or 1/4. Tama ba ako? 4 times 24. So, yung analysis natin by area, at ito analysis by actual, ito lang ang contribution niya doon sa pagbaha dito sa may area ng Tugigaraw. By the way, Bunton Bridge is nasa Cagayan mismo. Ito yung bridge na ginagamit natin pagpasok doon sa Tugigaraw coming from the Manila area. Daan tayo sa Bunton. Eventually, pupunta tayo doon sa Bunton Bridge. Ito rin...
Max, sorry, please wrap up.
Okay, sir.
Thank you.
Ito lang po, nung mga panahon na yon, dito na po tayo nagbibigay ng pre-releases. Dito pa lang nagsisimula na ng PAASE at sa kaniya magre-release ng dam. As you notice, ito yung dam discharge natin. So medyo maliit yung mga discharge natin, but this is already significant. And then dito talaga, pagdating ng panahon na malakas talaga yung inflow, ang nangyari na dito, inflow ay naging equal to outflow na ang ginagawa ng NIA. So from here, I think thank you for listening.
Thank you, Max. Thank you. Salamat. Quick question, Max, while you're there. You mentioned na nagbigay na yung PAASE very early on ng warning sa Magat Dam of an estimated rainfall. And yet nagre-release na sila days before pero masyadong konti ang release nila. Why is that?
Sir.
Bakit konti lang ang release nila? You may know
as you notice, sir, ang value po dito ng mga release nila rito is around less than 1,000 cubics. Ikumpara mo doon sa 6,000 na maximum. Ang problema lang kasi dito, sir, no? As you notice, itong kulay blue, ito yung bunton. Hindi pa kasi tayo sigurado dito sa rainfall event, sir, na darating. So, actually, itong nakikita mo rito, kumpul-kumpul na pag-ulan, this is caused by another system, yung north tail end of the cold front. Ito po yung nagpaulan dito. So iyon lang po ang nire-release nila. Kung ano yung pumapasok dito, iyon din ang nilalabas nila. Noong mga panahon kasi na yun, sir, nanggaling na yung Pepito, Ulysses, ano pa ba yung Quinta, Sunya, Siony, ano pa ba yung ibang mga bagyo, yung 4 na bagyo, sir.
Rolly.
Hindi apektado sa Ofel, sir, but from Pepito. But from Pepito siya nagsimula. At sir, mga panahon na yon, puno na talaga ang dam din. At yung Bunton River ay medyo mataas na. As makikita po nimo, nasa alert level na rin po tayo ng mga panahon na yon. So,
I think, Max,
sir?
I think nabanggit mo yung problema eh. And that is, we should not do releases from dams of water that is already coming in. It's too late.
Yes,
Pero
sir.
you mentioned also na meron na kayong prediction na 165 mm of rain.
Yes, sir.
And this is days before, and yet hindi sila nag-increase ng release because of that prediction.
Ganun po yun, sir.
Okay, thank you. And while you're there, once and for all, pwede bang pakisabi sa lahat ng participants, meron bang kagagawan ang Angat Dam sa pagbaha sa Marikina?
Wala po, sir. Definitely wala.
Meron bang dam na nag-release at nagpabaha sa Marikina? Baka nakikinig si Mayor.
Wala din, sir. Wala din.
Okay, the only dam I know upstream of Marikina is Wawa Dam, which is non-operational. Ibig sabihin, all the water that flows through Montalban is not being held by any structure.
Meron din siyang kunting hiniheld, sir, doon sa Wawa.
But is that enough to make the floods in Marikina?
Hindi po, sir. Kasi pag napuno po yung dam ng Wawa, it will act as a weir. Parang aapaw na lang po siya.
Parang
Wala
waterfalls lang yun.
Parang waterfalls na sir.
Okay, correct.
Hindi kagaya sa mga design natin sa mga malalaking dams, meron siyang gate. Dito sa Wawa,
Walang gate.
wala siyang gate.
Pass-through.
Pass-through lang po siya doon.
Okay,
Meron
Max,
sir.
This is a question from Army Jean. Sabi niya, yung recent flooding sa Cagayan and Isabela, when you compare it to the high floods in the area during the 70s and 80s, ito na ba yung pinakamataas?
I'm sorry about wala kaming hindi pa namin ma-compare, sir, kasi hindi pa namin nagpo-post flood doon sa lugar na yon.
Okay. Thank you.
We can answer that one siguro kung mapuntahan na namin doon, sir. Karamihan ang mga ganyang mga tanong natatanong namin sa mga matatanda. At any rate, sir, siguro masasagot ko.
Sige. And
dahil nga siguro sa mga siltation na nangyari sa ilog ngayon, maging masasabi natin na worse na siguro ito ngayon. Pag silted na kasi ang lugar, sir, actually yun din na nakikita namin sa isang istasyon doon sa Tumawini. Nagtaka kami, bakit ang laki ng discharge na nakukompute namin base doon sa tinatawag nating water level kumpara doon sa Bunton, which is downstream. Ang assumption namin, sir, baka siguro silted na yon, kaya yung tinatawag natin na base value namin medyo mataas na. Kailangan taasan
all the more reason, Max, that the releases from dams need to be recalibrated because the capacity of the river downstream of the dams is no longer the same as when they were first computed in their dam release protocol.
Tama po kayo dyan, sir.
Okay, thank you. Gay, baka may questions na hindi ko nakita. You can
Yes, sir.
We now open the floor pala to questions. If you want to ask questions, you can raise your hand or type it in the chat box and Gay will read it.
Sige po, sir. So I'll read a few questions here, but before that, I just want to acknowledge Dr. Prisco Nilo, who is also with us. So he's a former PAASE administrator and he's now part of the IESM family. So he's been answering some of the questions
I know. Thank you, Dr. Nilo.
Chat box. Thank you po, sir.
And I remember with Dr. Nilo, baka you want to speak a little bit. This is 2009 all over again, when San Roque Dam actually released a lot of water, di ba?
Tama naman yung sagot ko.
Dr. Nilo, you want to comment po?
Baka later. Sige, go ahead.
Po.
Jay, baka may question.
Hello.
Hello. Hi, Dr. Nilo.
Yeah, good afternoon, everyone. I was just monitoring really and answering some of the questions. Una kong sagutin mo na yung San Roque kasi taga-flood ang kuan yan, dapat sasagot sila si Max. Yung mga questions mo earlier related to the rainfall during the passage of, sinagot mo na rin yon. During the passage of a typhoon in the Philippines sa panahon ng northeast monsoon season, similar to habagat, no? Nagkakaroon ng enhanced monsoon. So this time yung Typhoon Ulysses ay cross Luzon. So areas to the north would tend to have more rainfall due to the northeast monsoon. So that would explain the high amount of rainfall in Tugigaraw. I would also expect other stations in northern Luzon to register higher rainfall.
Okay, Dr. Nilo, while you're there, I was speaking with Dr. Amadore, who was also with PAASE, and baka sila June then can answer. These last 5 typhoons that passed by the country during the months of October and November are slightly unusual in terms of their track, because during these times, the typhoons usually pass by somewhere further south in Visayas and in Mindanao, no, because of the east-west movement of typhoons during this time. Pero itong 5 na to, medyo mataas siya. Napansin niyo rin ba yung characteristic na yon na medyo kakaiba? And maybe also Jerry can chime in.
Sir CP,
Yeah.
andito din po pala si Dr. Amadore. Dr. Yasha Amadore is here. Yeah.
Yes, I know
Yeah.
Dr. Amador is there, and that is one of his observations that we want to pursue.
Yeah, that's right. But more or less, malapit din siya sa climatological track ng tropical cyclones. Yung kay Typhoon Rolly, there was actually a binary interaction with the one following Typhoon Rolly was Ulysses, right? So there was a binary interaction between the two, resulting in the more southward movement of Typhoon Rolly. So sumusub-sub siya. And then afterwards, yung si Ulysses, ganun din, meron ding affect kasi nagbabinary yun eh. So more northward yung kanyang track. Anong bumitaw na, malayo na at naglandfall na sa Vietnam si Typhoon Rolly. Medyo mataas na yung track ni Typhoon Ulysses, which is a little bit north of the climatological track of tropical cyclones during the month of November.
Okay, thank you, Dr. Nilo.
Sir
Any more
CP,
questions, Gabe?
yes, I consolidated yung questions for Sir Jerry. No? Maybe Sir Jerry can comment on the other factors like ENSO, MJO, and Sierra Madre. Sir Jerry?
So currently we are in La Nina. So mas nasa mga -1 degree Celsius na sa Eastern Pacific. And typically, and so whether it's El Nino or La Nina, the effect kicks in around September, October, November. So yun yung typical na nangyayari. And possibly may kinalaman. And for La Nina, most of the tropical cyclones, they form just east of the Philippines. And the numbers are also higher comparatively to other ENSO phases. So it seems yun yung nangyari naman na most of the formation are to the east lang natin, very close. And since they're very close and late into the season, more chances of really making landfall. Yung MJO medyo mahirap,
Yes,
matagal yung explanation, so wag na lang yun.
Sige sir, yung Sierra Madre po, yung mountain. Did it make it worse or yeah?
It depends on which side. So definitely there will be a side wherein yung tinatawag na windward side where the wind hits the mountains. Definitely yung rains doon will be higher, and then the other side will be can be lower. On the other hand, yung bagyo, tandaan natin na gumagalaw siya. So yung windward side at one point of the tropical cyclone can be leeward on sometime later, di ba? Tapos magiging windward naman yung iba kasi gumagalaw siya eh. So once na naging windward, then it can exacerbate rainfall.
Okay, thank you po. Question po from Adrian Vasquez, I guess for PAASE, no? What is the general outlook for 2021 in terms of the typhoon frequencies, associated rainfall, and overall wind regimes? Will we continue to see this northward migration of tropical cyclone?
Baka isama na rin yung yung remaining days of November and December.
Yes, okay.
Typhoons?
Are we expecting, yes?
Ma'am SP or June?
As for the remaining months, sir, for December, 1 to 3 tropical cyclone pa ang inaasahan natin for December. Pero for next year, wala pa po tayong forecast doon.
Thank you po.
1 to 3. 1 to 3 pa.
Okay.
Yes, sir.
Okay. Thank you. Pero wala pang within the coming 7 days.
Well, sa ngayon, sir, wala po tayo na monitor.
Okay, thank you.
Another question po for PAASE po siguro, more on the communication aspect. No? Does PAASE give rainfall advisories in Facebook in laymanized Filipino languages? I think some or most Filipino uses Facebook. So baka daw po pwede i-maximize yung Facebook platform that does not use much images. So more on the text based siguro and Filipino languages. So anybody from PAASE po might want to answer
lang
that.
po. Actually, yung mga sa PRSD stations po natin, nagre-record sila ng sarili ng forecast in their own dialect. Kaya mas naintindihan po, halimbawa sa part ng Visayas, sa Visayas dialect, sa may Southern Luzon, Bicol dialect, ganun po. Tina-translate na po sa own dialect nila sa mga PRSD natin.
Sige po. Thank
Siguro
you po.
June,
Yes.
June yung tanong would be more like instead of numbers in terms of millimeters of rainfall, kasi konti lang naman tayo nakakaintindi kung ano yung itsura ng 10 mm of rainfall per hour, di ba?
Actually sir, hindi na tayo nag-focus ngayon masyado sa value. Nagbibigay na tayo ng halimbawa yung light, moderate, heavy, intense, torrential. Yun na po yung pinapaliwanag natin ngayon sa tao. Nag-deviate na masyado tayo sa dito sa mga values.
Okay. Well, of course, yung classification na yun are still based on the ranges in terms of millimeters per hour, hindi ba, June?
Tama po, tama.
So intense rainfall is 30 mm per hour or more. Pero baka yung mga tao hindi rin naintindihan kung ano yung intense. So
Yes.
meron ba tayong way of making them imagine na yung ulan at baha ay kalahati ng ondoy?
Yes, so actually sir, meron ongoing project ngayon with the RDTD, yung impact based. Magfo-focus na sa impact, hindi na sa value ng rain. Doon sa mararanasan nilang possible na mararanasan nilang impact. Ongoing na po yung project ngayon na yan.
Thank you. Gay?
Yes, sir. There are a couple more questions related to flooding naman po. I'm just looking at that time. Can we still continue, sir? Okay lang po ba?
We'll continue for 10 more minutes and then
Okay, sige
we'll
po.
call it a day.
Okay, so for flooding, I guess questions are along the lines of what can be done to improve flood warning system for low-lying areas in order to allow residents to prepare and evacuate. Also, could there be ways to monitor regional soil water content or at least identify flood-prone areas based on soil saturation? The other questions are related po, like recommendations. What are recommendations to prevent such massive flooding in the future? So anybody po would like to comment on that?
Siguro Max, what do you think happened in Marikina? Bakit naulit yung Ondoy event? Or baka wala na si Max. Ma'am SP, if you want to answer, what do you think happened in Marikina and people were surprised of the levels of flooding again?
Sir, baka wala na din po si
Baka wala na.
SP.
June, baka ikaw na lang. June,
Sige.
Sige po.
Actually, sir, 11 years na nangyari yung kay compare kay Ulysses. Parang
Sir,
nakalimutan.
within 11 years, may mga hindi natin alam, may mga pagbabago na nangyari dito sa may Marikina area. Baka yung
Si Max
river
na
doon
lang mag-explain, June.
Sige. Go ahead, Max.
alam natin sir sa Marikina River, hindi pa tapos yung flood control system nila. So, actually may mga lugar na parang kinukonstrict nila yung daanan ng tubig. At meron patsi-patsi lang po yung pagkagawa pa ng mga flood wall. So, maaari sir, mataas talaga ang tubig. Doon sa mga butas na hindi pa naayos yung tubig, yung flood wall or hindi pa na-construct, doon po dumadaan. Ang problema ngayon sir, talagang tataas dito sa floodplain dahil pinapaliit nila ngayon ang yung tinatawag natin drainage, yung kanal mismo at ginawa nilang konkreto. And then during also that time, sir, malakas talaga ang pag-ulan upstream na nakaregister dito sa mga istasyon ng PAASE at yung mga istasyon na nakukuha namin galing sa FCOS, which is yung galing sa project sa MMDA. It reaches, ang mga ulan po nila doon sa event rainfall, maabot po ng mga 200 plus millimeters within the event. So iyon po yung mga ulan na yun na nadala hanggang dito sa may Bulacan River, hanggang sa Angat River. Eventually, pag dating doon sa may area ng Nueva Vizcaya, iyon din po. Dahil hindi naman po humina yung bagyo natin. Tuloy-tuloy po yung pag-intensify niya kahit dumaan na siya sa kalupaan. So, at ang maging initial conclusion ko dun, sir, malakas talaga ang pag-ulan. At widespread po siya. Hindi kagaya sa Ondoy, ang malakas na nakaregister na pag-ulan lang po ay dito lang po sa may Science Garden. Do we have, Sheila, do we have that comparison ng ulan? Nandito ba? Wala, hindi po namin naisama dito yung comparison ng ulan, sir, ano? Between Ondoy at saka ng Ulysses. But at any rate, sir, I don't know kung may time pa ba na Sheila, could you, kung ma-describe ba namin yung rainfall rate na na-obserbahan?
Maiksi lang, Max.
Sir?
Maiksi lang.
Yeah, one page lang po, sir. Hindi lang nailagay rito. Kasi
So in summary, Max, you're saying that there are certain factors that affected the flood heights in Marikina, including some of the structures being built as flood control. And because they're being built, there are portions of the river that were constricted.
Opo, sir.
Okay, thank you.
At hindi pa rin natapos yung iba.
I got that. We actually have a project in UP together with our counterparts in the UK. I saw one of our colleagues, Rich Boothroyd here. Our project is actually to look at flooding and intervene flooding downstream by doing interventions upstream, more soft structures instead of putting dikes and pumping downstream.
Ang hindi ko lang maintindihan, sir, kasi ginagawa naman kasi ng public works itong kanilang trabaho itong pag-aayos sa Marikina River. And I wonder bakit nila kinoconstrict yung laki mismo or yung width mismo ng river system. At makikita naman po natin yan pag punta tayo roon. Halimbawa, susurbihin. Bakit parang minumove na doon sa gitna ay yung mga flood wall. Hindi mismo ni-utilize yung laki mismo ng ilog.
Okay, so may pruweba tayo na kinonstrict nila yung ilog. Dapat medyo sinakop niya yung parte ng floodplain instead of putting the dike right beside the river.
Yes, sir.
Okay. Okay, thank you. Ngayon ko lang narinig yon. Any last questions? We have 5 minutes left. Okay.
Sir, I just want to read a comment from Lisa Socorro. Sabi niya po, I think LGU should consider geohazard information in the CLUP, appropriate land use plan to be safe from flood hazard. I think we cannot prevent flood from happening. Flooding is part of the river, nawala biglang
process.
Yes, river process. Sige po, thank you.
That's a good comment, Lisa. And I don't know why the CLUPs are just a report and not actually used in actuality.
Dr. CP, good afternoon. I'm in Ilocos Norte right now in the field. I just would like to listen to add, get some information about Ulysses, but parang hindi ko mapigil ang damdam because I once lived in Provident Village, and way back in the 80s, umaabot na po ng bubong dyan, kaya umalis kami. Umaabot na po ng second floor yung flood. That was in the 80s. And you know, there are open spaces there. So siguro if you look at, hindi lang natin titingnan yung mitigation measures, titingnan din natin yung proper location ng ating mga structures. Nang bumalik ako after 20 years, nagulat ako, almost paved na po ang Marikina. Wala na pong soil infiltration. Puro konkreto na po. So, hindi lang yung mitigations on the river Ano pong ginawa natin sa floodplain? Yun lang po ang gusto kong i-comment, Doc CP.
Thank you, Lisa.
Yes.
Yes, you are completely accurate. Other questions, Gay?
Sir, may pahabol. Is there any ongoing study to update estimated sediment load in all affected basins, watershed? Like channel siltation is being pointed as one of the factors which reduce the capacity of the rivers, but there might be insufficient info to determine how much sediments enter the channel. So question po from Malvin Manuel.
Hi Malvin. We have an ongoing project that tries to estimate sediment load from actually all Philippine rivers. It's ongoing and we have 1 year left to complete the project with our UK counterpart. So I believe that's the first study to try to estimate sedimentation in the rivers, including erosion, and obviously it has impact in terms of flooding in those rivers.
Okay po. Sir, kaya niyo pa pong sumagot? Isa pa. A study in 2001 made by JICA cites many recommendations to control the flood in Cagayan River. Do you support this? This is from Marcel Dabu. Si Dr. Siringan po siguro, no? But
hindi ko alam
here.
yung details ng 2001 study pero maybe our PAASE friends can answer. Marami namang studies even for Marikina. But usually it's in the implementation. Usually it's the wrong intervention.
Sir, could I say something?
Yeah, go ahead.
Pag mga study kasi na ganyan, sir, more or less, kung structural po yung aspect na pinag-aralan, sa public works po ang may hawak, ang rather ang nila dyan, host nila. Karamihan sa amin, sir, sa non-structural. So, more or less sa pag-asa sa early warning system lang po.
Thank you. So, I think yun nga yung sinasabi ko earlier, some of the intervention measures that we are used to doing, like dikes and pumping water out of the river and dredging, these are all very helpful, but their effectivity is very short. One event and you silt the river, bring down a lot of sediments, then it renders some of these projects unusable anymore. That's why we're also promoting interventions upstream, not only reforestation, but soft engineering structures upstream. Baka ito ay mas long-term na solusyon sa pagbaha. From Ed, did Typhoon Ulysses affect the New Clark City? Well, it passed by Angeles, and New Clark is in Tarlac. Does anyone know? I'm sure naapektuhan din yun. From William, would a dam on upstream or upper tributaries be an ideal solution in the Cagayan River Basin? Another dam, Max? Pwede siguro, but again, any structure that you put in upstream of a natural waterway, you need to manage it and monitor. And in the case of Magat Dam, if you mismanage it, then the problem actually increases. In fact, Max, meron akong tanong sa iyo about the 1/5 contribution of Magat Dam to the entire flooding in Tuguegarao. Maybe that's accurate if there's no dam in the area and we just ratio the size of the catchment versus the entire catchment. But remember, Magat Dam actually stored the water during the whole rainy period of Ulysses and released it in a very short period of time. So it's not like the rainfall that's going to be spread out over a period of time, but this is a release that's very short. So baka a little bit more than 1/5 yung contribution niya dun sa pagbaha. Just my thought.
Sir?
Yes, sir.
Ganito po yan, sir. Ano? When they open the gate, parang tuloy, ano yan, sir, parang naglalaro sila eh. Meron silang mini-maintain na tubig at the instant. Halimbawa, itong oras, ito yung mini-maintain nila, 190. Ngayon, pag tumaas na yan, sir, tinataas na naman nila. So what I mean to say, what comes in must go out. During that event, sir, ang nangyayari, ang dam parang naging ilog na lang. Kasi kung ano yung pumapasok, iyon din yung ilalabas nila. Dahil kung ipunin mo siya, no? Pag ipunin mo siya, tataas pa rin siya. Kung hindi mo tama yung pagbukas na yon, na doon pa rin meron pa rin tubig na meron pa rin pagtataas doon sa level ng dam. So ang ginagawa nila diyan, sir, the record shows naman, sir, na halos mga panahon na yon nagli-level up na yung tinatawag nating elevation ng dam. So what comes in, iyon talaga ang ginagawa nila, sir.
Okay. Got it, Matt. Thank you. Okay, we are over time. Gay, final words from you. Hello, and Jerry.
Si Vic ito.
Vic? Vic, you're there?
Yes, sir.
Yung ano pala, sabi ni Max, di ba, kung what comes in must comes out. Must go out, di ba? Pero nakita namin yung nirelease ng Magat, mas mababa pa kaysa inflow. So ibig sabihin, nare-retain pa yung iba. So hindi talaga hindi yung pinakawalan ng bigla. Nag-meeting kami kahapon with Nia.
And while you're there, Boss Vic, bakit hindi nila tinake into consideration yung initial warning ninyo na 165 mm of rainfall, and why did they not increase their release?
Mayroon kasing yan, Sip eh. Mayroong requirement kung anong oras sila magpalabas mula nung magbigay sila ng warning. Mayroong 6 to 8 hours na requirement at hindi din sila pwedeng magpalabas kung aabutan sila ng alas 5 ng hapon.
Okay. So I think, by the way, everyone, we are joined by Dr. Vic Malano, who is the head of PAASE. So I guess that there was a comment, Gay, earlier about dam protocols. We probably need to review it again, for Magat, because they all operate on very strict rules and guidelines. And at least for the case of Ulysses, nag-release sila ng tubig during the time na baha na rin dun sa ilalim. So if on hindsight, sana nakapag-release sila ng mas marami-rami earlier.
Tama nga, dapat nga siguro i-review. Pero in fact, mayroon na yung prepared na operating manual na na-prepare noong 2012 na hanggang ngayon ay hindi pa napirmahan ng lahat. Ang pumirma niyan ay 3 pa lang, PAASE, OCD, tsaka yung National Power Corporation. Yung ibang dam operators hindi pa. Kahit yung 1984 hindi yun napirmahan yung operating manual. So kailangan nga siguro dahil 2012 pa yun eh. So
might as well i-review na natin tapos papirma.
Kaya na nga eh.
Okay. Thanks, Boss Vic.
Okay.
Last words, Gay?
Sige, sir. Okay. Well, actually, sir, maybe I'll answer also one of the questions from Malvin Manuel. Kasi po, twice niya tinanong, do we have ways to monitor the regional soil water content in the Philippines or at least identify flood-prone areas based on soil saturation? So I cannot answer the second one, but the first one, in terms of monitoring, so there are efforts po from PAASE, DOST-ASTI, and BSWM that set up network of moisture sensors, no? So soil water content, and similarly po to use that together with or to complement that with satellite observations. So in terms of monitoring po, I guess we can use that. Now, in my comments po, I feel that so there are recommendations on reviewing protocols and maybe policies. So I think that's very timely. I just want to reiterate perhaps the value of hard data when making these recommendations. So Ma'am Lisa earlier said that back in the 80s, Provident is already flooded. No? I guess the more that there is a need for maybe compilation of this environmental data, so we have a solid baseline and reference po when we make changes in our protocol and policies. So yun lang po siguro. And right now we have this through PAASE's network, and our satellite observations are a good resource to complement this data set. So,
thanks, Gay. Well said. Marami pang kailangan pag-aralan dito sa Ulysses, and hopefully we are able to correct some of the mistakes we made. Dam protocol ba man yan, or not considering the other factors like siltation and soil saturation. These are all very important things that scientists and engineers need to work on. And we just hope that it feeds into policy and actual projects in the future. Thank you everybody for coming. We have to close, it's 5 p.m. I hope you learned a little bit from all our speakers this afternoon about Typhoon Ulysses. I certainly learned a lot, and rest assured that the research that's being conducted in PAASE, in UP, and all other institutions will continue, and hopefully improve our way of dealing with disasters and climate change in general. Maraming salamat everybody. Thank you. I can't say thank you to everybody, but I see Rene, Doc Bill, Brother Mike. No, thank you everybody. I know Ma'am Rosa and Dr. Amadore are also there. Maraming salamat. Dr. Laraya, of course. Thanks, Gay and Jerry, for sharing your data, and our friends from PAASE. Maraming salamat.
Thank you po, everyone. To our colleagues from IASM, thank you.
Also yeah, Olive is there.
Yes po.
And Dr. Nilo.
Parang full force po sila. Dito din po si
force.
Ma'am Maylene, Dr. Moya, and
Dr. Moya, yeah.
And
Okay.
Doc May Legaray, our new faculty. So,
if
Alex is here, so we're all here po.
If we get more information, collate them and new findings, maybe we can do another webinar on this. Okay.
Thank you po. Thank you,
I hope
everyone.
everyone's safe. Thank you, everybody.